Hello, welcome to another video by George's Shed, and in today we're going to be covering episode 2 of the DAA Autonomous Aircraft Project. So as per the board that we discussed in episode 1 and the introduction, this episode should be mostly about the servo control system. However, spoiler, it's not going to be. And this is because I've already started to build the servo control system. I've run into some issues that need sort of a bit of a redesign of particularly the transmit module. So I'm now going to explain exactly where we are with this project. Okay then, so currently the system consists of these two main parts. I've decided to call these two parts the drone system and the ground station system. So the ground station system is perhaps the slightly simpler module, and it currently consists of an Arduino Nano, a 3DR module and an LCD. So this obviously allows it to receive and send data and display it to me on the ground. We then have the drone station, which is perhaps the more complex one and where the current issues lie. So this currently consists of an Arduino Nano as the core processor, then has a receiver which it reads in a PPM signal from. We have the 3DR module which communicates via serial. We have a server and we've got a voltage sensor. So the issue I'm having with this module is essentially that the Arduino Nano isn't powerful enough. So the issue is that the Arduino Nano only has one serial channel which I primarily use for USB debugging. So that means that the 3DR module, which communicates via serial, is doing so via a library called software serial, which is great, but it's quite slow because it's obviously not a hardware serial, it's doing it all in software. And basically the entire system grinds to a bit of a halt. The issue at the moment is that the server, there's only one PWM output for the server, and the server is quite jumpy and jittery, suggesting that the two timers on the board are being saturated, and that's cause for the slight variation in their PWM signal. So the hope is to update this system to an STM32. So on an extremely messy desk, I've started work on the STM32 controller station. So here is the new board. So you can see I've already been prototyping with the 3DR module. I'm also trying to go a bit more fancy. So I'm using actual JST connectors for the connections, which are a bit nicer and a bit easier for testing and moving stuff about. So the core of this is obviously the STM32, which is an extremely cheap but powerful processor. It's cost similar amount to the Arduino Nano, only sort of 3 or 4 quid, but offers a lot of power. The only issue with it is that it has 3.3 volt logic, but so far I've discovered that the 3DR modules do work fine on 3.3 volt logic, so that is going to be quite nice, but obviously we need to dig further to see what other modules potentially may have issues. So as I said, this board's quite simple so far. We've got the STM32, which does not have a USB programmer built into it, so you need to use one of these FTDI breakout pins. So I've also built this this little adapter that simply goes from the FTDI breakout tool and goes into the Arduino Nano. So if I plug this in, hopefully everything lights up, which it does. So this is how it'll be programmed from now and into the future. And then obviously you can see some of the wiring done so far, but this will obviously expand into the future. So if you look at the lights on the radio, I've currently got working just testing the serial communication. So every time the red light flashes, I'm not sure if you can see it, but it's sending some data. Doesn't really matter yet. So that is the processor. Obviously the handheld ground station is exactly the same. I'm not changing the core functionality of that. However, what I am going to add is a little keypad, and that allows the screen and values to be added and changed. So then there's one other section. Where is it? So here because obviously with all the connectors on here for all the different things, I'm not sure if there's going to be enough room for all of the server connections. So I've built another board here, so there's lots of space on here for potentially changing the layout of the servers. So you can see I've started off with 7 channels, and then we've got obviously one PPM channel, and then this is just going to be connected to this board via some more of these connectors. So I'll come back in a bit when I've done some more work. So we're now many weeks into the future and some more work has been done. Here you can see the drone module, and the multiple things have changed, or well, not really, but things have been added. So you'll now see that the receiver is connected, and this was probably one of the hardest things to do up to this point. So this probably took me about 2 months to figure out how to do, and that was finding out how to program the STM32 to read in a PPM signal. And that means that we only need to use one wire to read in all 10 channels from this receiver, and that obviously saves up a lot of space and processing power, because it can be just be done using one timer. It also means that we can use a lot smaller receiver. At the moment I'm still using the 10 channel one because I don't have any other one, but you can obviously buy micro receivers that just output PPM, that are very small and very light, which is important for an aircraft. So this is now at sort of a working prototype stage. It reads in the voltage, it reads in the signal, and it sends this all to the ground station, which is the other thing that has been updated. So here is the ground station, and you can now see that it looks a lot more fancy and complete. So flipping it over, we've got the button keypad, which I've already shown, and this plugs into the same board as before on the screen, and I've just made it this nice 3D printed case for it. But that's also not all that's been done. A lot of work has been done in the back end to program it. Okay, so hopefully you can see the screen now, and you can see that when it boots it has this lovely setup message, and to continue we can press down. So we now have an actual menu system that is starting to take shape, making it a lot more usable. So we can see here we have 2 options. We've got the debugging option and the PFD option. So we're going to go into the PFD and see what that can tell us. So you can see here in the PFD menu, which is the primary flight display, this is going to have the information that you want to see when you're flying. So it'll probably have the different settings, what flight mode it's in, and battery and things like that. So if I actually plug in everything and turn on the transmitter, hopefully that value will change. So there we go, the battery is 7.7 volts, which is about right, and the roll is actively changing, so that's spot on. So we can now go back into the main menu, and we can go down to debugging, and if we go in there, I've created these 2 functions called keypad inputs, which is just going to show the state of these buttons and all the switches, so we can see if we've got a dodgy connection, and receiver inputs, which is going to have like the roll, the yaw, and all that, which I need to move from PFD. As you can see, this hasn't been implemented yet. So that is the ground station. Thank you very much for watching. I hope you enjoyed this episode, and please make sure to subscribe so you don't miss the next one, where we should be trying to get some servers connected and start to make things move, and maybe even an aircraft flight test. Please, I don't know what I'm doing. Bye. Don't know what I'm doing. Bye.